Hello, I'm Mr. Howard. This is part one of your Unit 8 exam review where we cover special functions. Alright, so this will definitely be in multiple parts because there are over 20 questions on the review. Okay, so first one, sketch f of x equals the square root of x plus 7 minus 2. So this is a square root function. Underneath with x is left and right opposite of the sign, so it's going to be left 7, and then outside away from x is with the sign up and down, so that's down 2. So left 7, down 2. So verbal is left 7, down 2. It would also be okay to do this, left 7, down 2. So we just sketch this in. We need to draw the critical point, which is our anchor point or our starting point. So that would be left 7 down 2 would be negative 7 comma negative 2 for that start point, and then it would just be like this. Alright, so that's question 1. Let's look at question 2 next. Alright, question 2. Sketch f of x equals the square root of 16 minus x squared minus 4 and describe the transformation. So we have an x squared term underneath the radical, therefore it is a semicircle. So let's draw an axis here. And then as far as describing the transformation, the only transformation is this minus 4 outside away from x, so that's down 4. So we have a radius of 4. My radius equals 4 because it's the square root of 16. The square root of this number is my radius, so my radius is 4. So we're moved down 4, so we're going to be over here at negative 4 comma negative 4. We're going to be over here at 4 comma negative 4. And then we're going to have the top part will be right here at 0, 0. So we have a semicircle like this. Alright, so negative 4 here, and 4, negative 4 there. Okay, and because it's moved down 4, it would normally be setting right here, but because it was moved down 4, it's down like that. Okay? Alright, let's look at question 3. Alright, question 3, write the function shown here and give its domain and range. We have a semicircle. It is upside down, so that's a negative. And then we know we have a square root. It has a radius looking right here at the center. It has a radius 1, 2, 3, 4. So this number is going to be 16. And then it's always minus. I am translated to the right. I'm shifted right. My center is right 1, 2. So I need to do parentheses, and right 2 is going to be an x minus 2 quantity squared underneath here. And then I should be up here on the x-axis, so I'll move down 1, 2, 3. So that's a minus 3 out here. So it's the negative square root of the quantity 16 minus the quantity x minus 2 squared minus 3. So then my domain in interval notation is going from negative 2 included to positive 6 included. My range has a bottom point down here. That would be at negative 7. That's supposed to be a bracket there. Negative 7 to my top point is at a y value of negative 3 included. Alright, so that answers that one. Let's look at question 4. Alright, question 4, write the function shown here and give its domain and range. So this is a square root. It's been reflected over the x-axis. It's upside down, so that's a negative out in front, and we know it's a square root. It's been moved to the left 1, 2, 3, 4, so that's going to be an x plus 4 underneath here to get that left 4 part, and then it's been moved up. That anchor point has a y coordinate of 1, 2, so it's plus 2 out here. So my domain is going to be x is greater than or equal to negative 4, and my range is going to be y is less than or equal to positive 2. If we put this into interval notation, it would be for domain -4 to infinity, and our range would be -infinity up to positive 2. Bracket with 2, bracket with -4. Alright, so let's move on to question 5. Alright, question 5. Given f of x equals negative x minus 2 quantity squared plus 4, sketch absolute value of f of x. So let's sketch f of x first so we know what this thing looks like to begin with. Alright, so it's a parabola and it's upside down, so it's flipped over the x-axis. It's moved to the right 2 and up 4. So it's right 2, up 4. So right here at 2, 4, and it would look something like this. Okay. That y-intercept is going to be important. Anytime with a parabola that you're not stretching in any way, horizontally or vertically, when you go 2 away from the vertex in the x direction, you're going to be 4 away in the y direction. So we're actually going through 0, 0, and we can prove that. If we set x to 0 here, we would have -2 squared, so that would be positive 4, times -1 right here would be -4, so -4 plus 4 is 0. So that would, when x is 0, y is 0. So it's right through the origin there. So if we sketch the absolute value of f of x here, remember that that rule is all of my negative y values, so all of this right here and this right here, they get reflected over the x-axis. So this stays the same, and the pink part there we're going to flip or reflect over the x-axis. So this thing ends up looking, we have this same shape here, so the vertex is still 2, 4, and then this part is reflected over, and it goes on forever there and on forever there, just like that. Alright, so let's look at question 6. Alright, so question 6 gives us the same parabola. So our f of x graph is still the same as it was over here. So, and now they ask us to sketch f of absolute value of x only. So remember, those rules say that our positive x's, so all of this right here, it stays and it gets reflected over. Okay, so all of the negative x's are actually going to be gone here. So when we graph this thing in here, the right side looks exactly the same as it did before. So it's there like this, and this point was 2, 4, and this point was 4, 0. So when we reflect this thing, it's going to look like that. And this point would be -4, 0. This point would be -2, 4. Just like that. So that's how that one would look. Alright, let's move on to question 7. Alright, question 7 says, using the given function, sketch absolute value of f of x and f of absolute value of x. So we'll do absolute value of the whole thing. So absolute value of f of x first. So remember, that's like the absolute value of all of our y coordinates. So that means that everything below the x-axis, so all of this is going to be reflected, and then the lower part is erased. So it's erased but reflected. So that looks like this. That's this section right here that we just reflected, and then the top, everything above the x-axis stays as it was. So that looks something like this, and then comes down. Now we're going to reflect that little piece, so it reflects up like that, and then everything above, all of this stays as it was, so that comes up like this and then over. So that looks something like that. And then they ask us to do f of absolute value of x only. Alright, so that's just the absolute value of our x's. So that means everything to the right of the y-axis. So all of this positive stuff stays and gets reflected. So we'll draw what's staying first. So it's like this. And then we take that and just reflect it. So it looks something like that. Alright, so absolute value of f of x, you take the negative y's and flip those over the x-axis. Everything below the x-axis is completely erased. For the f of absolute value of x, you take all your positive x's and they stay, and then they're reflected. And all of the original graph that was to the left of the y-axis is completely erased. Alright, let's move on to question 8. Alright, question 8 asks us to graph this piecewise function. Alright, so let's draw an axis here. So we have y equals 5, so that's a horizontal line segment from negative infinity to negative 2. So if that's negative 2, 1, 2, 3, 4, 5, so that would be a solid circle because it's at negative 2, it's defined here, it's filled in. So it would be to the left like that. Alright, and then the next piece is a semicircle with a radius of 4, and it's moved to the right 2. So radius of 4 would normally be out here at negative 4, but it's moved to the right 2. So it's going to start at negative 2 here with an open circle because it's not defined here at negative 2, and then it's got a radius of 4 like we talked about. So the maximum point up here would be 1, 2, 3, 4 away in the x direction, and 1, 2, 3, 4 away in the y direction. So I'm going through that point, and then 3, 4. So it would be 5, 6. It would be out here at positive 6, and there it is defined, so it is filled in. We have an equal to there, so it's filled in, and then we just put our semicircle in like that. Alright, and then we're back to the y equals 5 again, so horizontal line segment from 6, not defined, so it's open there all the way to positive infinity. So it looks just like that. Alright, that's it for that one. Now let's look at problem 9, and that's going to ask us about problem 8, so I'm just going to go ahead and work with that. Problem 9, if you're looking at your assignment, it says in problem 8, what are the locations of any discontinuities? So that is occurring. You can always look in your domain statements pretty quickly and find them. It's negative 2 and 6. That's the answer. So when x equals negative 2 and 6. And you can see it here. At an x value of negative 2, we pick up at our pencil. At an x value of positive 6, we pick up our pencil. And again, you can also see them here in these domain statements. Alright, let's look at question 10 next. Alright, so 10 says, sketch an example of a function that has discontinuities at x equals negative 2 and x equals 5. Okay, so what it looks like doesn't matter just as long as it has discontinuities at x equals negative 2 and x equals 5. So I can just put here at x equals negative 2, I can put a solid circle here and line segment going that way, and then an open circle here at negative 2 still. So there's my discontinuity. I'm going to come over here to 1, 2, 3, 4, 5, and I'm going to put a solid right there and make it discontinuous here, and I'll draw an open like that. Okay, so discontinuities at negative 2 and positive 5. What it looks like really doesn't matter. You're just picking up your pencil at x equals negative 2 and x equals 5. That's all a discontinuity is. Alright, let's move on to question 11, and we'll do that in part 2. So that'll be the end of part 1, questions 1 through 10 in part 1. See you in the next video.